everyone. I guess doing good. How come our class looks kind of empty? Is it because of the veteran day? I don't understand this. Like all the schools are off and all the offices are off, everything. But CUNY is fun. We have class in CUNY. It's so weird. Yes. But you're lucky. We have one day more to study. So it's a good thing. And if you notice, I actually posted our review sheet for exam 2 on Blackboard. And I also posted the lecture material for chapter 10, 11, 12. I forgot 5. I'm going to do it later. So my plan is to give your exam on 25th. So today is 11, 25th will be 2 weeks from today. 2 weeks from today. And we are already done in chapter 9. And we are currently in 10. Most likely we will be able to finish chapter 10 today. So if you finish chapter 10 today, then we have chapter 11 and chapter 12. So your exam most likely will be based on chapter 9, 10, 11, and 12. If I cannot finish 12, then whatever I finish, the exam will be up to that point. But I made this review sheet. It contains everything for the rest of the semester. Chapter 9, 10, 11, 12, and also chapter 5. So definitely 5 will not be in this exam. It will be in the final exam. But I'm going to just put all the information, all the important things, all the important information you need to know from chapter 5 here. By the way, I'm not making the final, the department is making it. So I'm not sure what will be in the final. So they can see the final before the final, then I can modify my lecture and tell you, teach you based on what will be the final. If I don't see it, it's up to your luck. But definitely our second exam will have chapter 9, 10, 11, 12, probably have. Still get a cheat sheet. Two-sided cheat sheet. And in the second exam, we have another one-sided cheat sheet. And if you observe, I actually put all the necessary information, all the, not all the, like the formulas. The formulas you need to use in every section, I put them on the top before I giving you the questions. So for example, in chapter 9, we have 3 things. The first thing is the proportion, and this is one example of proportion example. Then second thing is for the, when we know our population standard deviation, this is the formula I need to use, and this is one example how the question will be. And then we have, when we don't know population standard deviation, then we use T, and this is one example of the T distribution. Similarly, in chapter 10, we had 3 things, proportion, Z, and T. In chapter 9, we were working with confidence interval. In chapter 10, we are working with testing our hypothesis. But we have the same scenario. If you have proportion, then we use Z, proportion information. And if you're working with mean and we know population standard deviation, then we use Z formula to get the Z statistic. But if you don't know population standard deviation, then we use T formula to get the test statistic, T test statistic. And if you do use Z, then I already put together the table for you. For Z, 1 tail and 2 tail for given alpha. You just have to have it in your cheat sheet. And if you want to work with p-value, then this is the rule for p-value. But personally, I like to work with critical value instead of p-value because p-value is kind of harder to get for the T distribution. And then these are the different types of questions you expect to see in the exam from chapter 10. So we already went over the proportion one, the first one. and we are gonna go over other questions today. So proportion is already done. Then we have two more topics left in chapter 10. One is testing the hypothesis when the population standard deviation is known, so we use Z, and testing the hypothesis when the population standard deviation is not known, so we use T. So we are going to do these examples today, and then we'll be done with chapter 10. So on Wednesday, we'll start chapter 11. That's my plan. And chapter 11 talks about two populations. So in chapter 10, you're working with only one population. In chapter 11, we're going to have two populations, so you're going to compare them. And for the comparison, we have this test, two population paired sample, but we have many other things. I'm going to introduce you to those to you, but those will not be in the exam. Whatever will be in the exam is from the review sheet. Chapter 12, we have chi-square test. Chi-square has two types of tests. One is fitness of goodness of fit test. It's when you work with one population. And we have independent test when you work with two populations. So final exam, our department chair, not chair, like our coordinator, she loves chi-square independent test. It takes time. It's time consuming process, but she loves it. Okay? So probably we'll see that in the final exam, but I definitely don't want to give that in our in-class exam. For in-class exam, if I give something from the chapter 12, it will be fitness of goodness of fit test. It means you're working with one population, and it's simpler to work with. And chapter 5, these are the five topics, important topics from chapter 5. And if she gives anything from the final anything in the final exam from chapter 5, it will be one of these. Okay, any question? Comments, concern, complaint, anything so far? Okay, so in our last class, we worked with one proportion, and we said in order to test the hypothesis for proportion, first we need to find what is sample proportion. So proportion means a sample size is given, and among all those people we have in the sample, there are only certain amount of people that share the same characteristic. So proportion means those people over that sample size. And that is the sample proportion. Population proportion will always be given either directly or with a hint. And population proportion, we denote it by small p, and our hypothesis is always based on population characteristic. Either it's on p or it will be with mu. Okay, so you cannot make your hypothesis like x bar equals something or p hat equals something. No, hypothesis is never for sample. Hypothesis is always testing something for the population. So we have to use the population parameters like p or mu. And then in real life, we check these assumptions, but in this class, we don't. We assume everything is true. And then when it tests our hypothesis, we need to find test statistic and critical value. Test statistic for proportion is using the Z formula, and Z formula has P hat and P, so you're going to apply all of those in the formula, you're going to get a number Z. If you want to work with P value, then you need the Z, but if you don't like P, like me, then we go for test statistic, which is we use the critical value. So critical value means we just look at the Z, we go to the Z table, and then we get the number from there. And we compare test statistic with the test critical value, or we compare p-value with the alpha. Alpha will always be given. Either they will tell you test your hypothesis at alpha level this, or they will tell you with 95% confidence test your hypothesis. So either confidence level will be given, or alpha, which is significance level, will be given. And then by comparing them, either we reject the null or we fail to reject the null. And then based on our conclusion, we make a reasonable conclusion, a statement. So we're going to do the same thing today, but this time we are working with population mean. When you work with population mean, we have two scenarios, either for the population we are working with or we are working for, we know the standard deviation for that, or we don't. If we do, then we test statistic. If we don't, then we use T test statistic. And for T, we need the degree of freedom. Degree of freedom means 1 unit less than your sample size, just n minus 1. Now, based on the scenario, based on whatever information is given, you have to decide which one to use. It means which information is given, you have to figure out. For example, here, suppose the IQ, excuse me. Suppose the IQ in a population is normally distributed with a mean 100 and standard deviation 50. Before going further, just by observing these two things, what information we know? What is 100? Mean for what? Sample or population? Population. And then what is 15? That means we know the standard deviation of the population. So we are going to work with Z. Now let's see what other information they give us. A scientist wants to know if a new medication affects IQ level. So she recruits 20 patients to use it for 1 month. It records their IQ level at the end of the month and found that their mean IQ is 103.05. What is 103.05? It represents what? Mean of what? Mean of sample. See, she tested 20 patients. So what is our sample size? 20. And that 20 people has a mean 103.505. Now, it's saying at 95% confidence level. So here they're giving confidence level, not alpha. At 95% confidence level, is there enough evidence to support the claim that the new medication affects IQ level? So it's a simple real-life scenario. She wants to figure out whether some medication actually really boosts IQ level. So she used those medications on 20 people, tested their IQ, and then found that the mean IQ is 103. What is the highest IQ? Do you know? No idea? Huh? Promise?
Doesn't make sense to say it's a highest IQ. Yeah.
Like among all the human beings so far, what was the highest IQ people found?
So I'll get out probably like 200.
Young age 200? 276? Wow. So they believed that the population has IQ 100, okay? And now the sample they tested, they found that their IQ is 103.05, the mean IQ, okay? So for population, they believe it's 100, but for sample, they found 103. Now they're saying that, well, based on the data we have, can we say that the medication they invented, it affects our IQ level? This is what you're testing with 95% confidence. Now, the word effects, does it tell us how it's affecting positively or negatively? Do we know which effectiveness we are looking for? No, right? They didn't ask, did the medication increase IQ level? or they didn't ask did the medication decrease the IQ level, right? They didn't mention increase or decrease. They only mentioned effects. But effects has two sides. Either it's affecting effectively, means positively, or it's not affecting effectively, means it's affecting negatively. It's only affecting. So do you see that you have two choices? Either you have positive results or negative results. That's why, can you guess what would be our alternative hypothesis? Remember, alternative hypothesis is the claim, always. Right. Because by default, we assume everything is positive. So by default, we assume it has an effect. So it doesn't affect what? Doesn't affect. How can you represent doesn't affect mathematically? If it stayed as 100, then it's not true. Because by default, we believe it's 100. Because population, by observing population, we believe our IQ is 100. Now, based on the sample, we have to make prediction about the population. That this medication increases or decreases the IQ level for the population. Because it definitely did for the sample, right? From 100, it got 103. It definitely affected our samples. But just based on 20 people, can you make the prediction about the population? Not yet, right? 20 people is too small. So we want to say that our null hypothesis is our IQ level is same as what we got before, 100. So IQ level, the mean IQ level. So which symbol is supposed to use? Mean means X bar or the mu? Definitely mu, because our hypothesis is always for population. So null hypothesis is mu equals 100. We believe that whatever we got, that's the truth until you prove it otherwise. So our alternative hypothesis is a claim. What they're claiming, the claim that the new medication affects IQ level. So they are claiming that the new medication affects the IQ level. How can you represent this sentence mathematically using mu? So we believe by default that our population has IQ 100. Now they're claiming, what they're claiming? Population does have 100, but it doesn't have 100. Which one? It doesn't, because it has an effect. They're claiming that the new medication affects the IQ level. So it's definitely not 100, right? So mu is not 100. We cannot say mu is bigger than 100. We cannot say that that medication increased the IQ level. Or it cannot say the medication decreased the IQ level. They did not mention that. Or this is not what they are claiming. They are claiming that the medication has some effect. We don't know is it the effect is it positively or negatively. We don't know its effectiveness. So we have two tails. Two tails means there are two choices. So we claim that, oops, what's wrong with this? Based on the information and based on the claim, no, one more. So based on the statement, we write our null hypothesis, our alternative hypothesis as mu is not equal 100. And this is telling us that the alpha we are working with, it has to be two-tailed alpha. So two-tailed alpha. Because it's two-sided. Not equal means two-sided. Two-sided means two-tailed alpha. Two-tailed, if you remember, it means we have one portion on the left, one portion on the right. So we don't need both of them, we only one of them, so it's called two-tailed. But the problem is they did not give us alpha. They gave us confidence level. From here, how can we figure out alpha? Do you remember? Promise? 1 minus the confidence level in decimal. So confidence level is 95%. So in decimal is 0.95. That gives us, what is our alpha? 0.05. So we are testing our hypothesis using two-tailed alpha. And since we have population standard deviation, so we are going to use Z statistic. So step 1, we found our two hypotheses. Null hypothesis and alternative hypothesis. Step 2, we need to know our test statistic. In this case, we are going to find Z. So Z is X bar minus mu, our standard deviation for population, divided by square root of n. Right? Yep. Oh, by the way, this is called hypothesized value. Hypothesized value. Hypothesized value means what number you have in your hypothesis for the population. So that's why these things has hypothesized value. It means look at your hypothesis and see what number you have in there. So we are given all these things. Our sample bar is 103.05. Population standard, population hypothesis, population mean is 100. Standard deviation is 15, and we have total 20 people. Find out how much it is. And remember, for denominator, you must start with a parenthesis and close with a parenthesis. Otherwise, if you put this divided by this divided by that, the answer you get is wrong. Nine zero nine three 0.909. Are you sure this is too small? Is it correct, sure? Yeah. The math looks hard, but it's too small. Okay, so step 3, we need something to compare. So we go to, let's see, p-value. What do I have? P-value, right? Let me see, what do I have here? P-value or critical value? If one is critical value, it's already given. So let me choose critical value. I don't have to do any math. And I'm too lazy to math. So let's find the critical value from the table. The critical value. So we have a 2-tailed alpha 0.05. 2-tailed alpha 0.05 Z. So I gave you the table on the cheat sheet, on the review sheet. For 2-tailed alpha 0.05, this is our, why can't I, oh, I didn't select. This is our Z critical value. 2-tailed Z critical value for alpha level 0.05. So just go to the table, get the number, it's 1.96. So we didn't need to do any math, it's simply 1.96. So this is 0.09 and this is 1.96. Next step, we compare them. Step 4. So we have Z critical versus Z stat. And when you look at them, we look at their absolute value. You see, ignore the sign. So what do we have? Which one is bigger? Critical is bigger, right? So for critical bigger, do we reject the null or we fail to reject the null? Fail. We fail to reject the null hypothesis. It means whatever we initially thought, we don't have enough evidence to reject that. So we fail to reject the null. Since we fail to reject the null, now comes step 5. Tell us, what does it mean? It means at 95% confidence level, there is not, we do not have sufficient evidence to support that claim that the medication has an effect on the IQ level. So it fails to reject the null. It means we don't have enough evidence to support our alternative. Fail to reject the null means whatever we initially believed, we cannot reject that. We still firmly believe that. And you guys are so smart, you already realize that will be the answer. That just based on 20 samples, we cannot make a general statement for the population. It doesn't make sense. So at 95% confidence level, no, it doesn't make sense. We don't have enough evidence to support the claim they are claiming. So we stick with the initial one. The population standard deviation population mean is 100, and that medication, we don't know whether it's an effect or not. So in the exam, you're going to do all parts because all the parts have different points. So step 1, step 2, step 3, step 4, and conclusion is in step 5. So you're going to do all 5 steps. That's it, to be very careful because if you miscalculate one step, it means all the other steps are wrong. You're going to answer them wrong way. Especially if number 2 is wrong or number 3 is wrong, that means definitely number 4 is wrong. Step 4 will be wrong. And if step 4 is wrong, the conclusion you're going to make will be wrong. So be very careful. Any question? No. Was anything confusing or unclear?
They'll reject the all.
No, we always fail to reject the now, not out.
No, we always have to reject no when the grid is higher than the stat. And when it's smaller,
We reject the now. So when you reject the now, it means we have enough evidence to support that claim. But when you fail to reject, that means we don't have enough evidence to support the claim. Can I flip my page? Try the next one by yourself. A teacher claims that the mean score of all students in his classes is greater than 82. With the standard deviation of 12. Then he took a sample of 81 students, found the mean is 90. So his claim is that the mean score of his students in his class is bigger than 82. That is his claim. Now, to support the claim, he observed 81 students and found that their mean score means mean exam score. Their mean exam score is 90. Now it's your job to check his claim at the alpha level 0.05. Is this claim true or false? Who is confused about the story, about the scenario what you are working with? Anybody is unclear about what is given? You know, it's better to be asked question here than suffering in the exam. If you ask question now, I'll help you so that you can prepare yourself for the exam. So make your hypothesis, alternative hypothesis, null hypothesis, find the test statistic, find the critical value, compare them, and make a conclusion. Question number 1, are you going to use mu or p? Which one in the hypothesis? What you are working with? Are you working with proportion or are you working with mean? Mean. So definitely our hypothesis has to have mu. Now what they are claiming, I should say what he is claiming, the teacher. What is his claim? That's the alternative hypothesis. Perfect. That mean will be bigger than 82. So what is our null hypothesis? No, equal. Alternative hypothesis so null hypothesis always has equal sign. For now, unless we mention it otherwise. So for now, it's equal. But eventually, if we take higher level statistic, it will be less than or equal. But in this class, our null hypothesis always has only the equal sign. Okay, great. Since we have a less than or bigger than sign, what type of tail we are working with? One tail or two tail? Never mind, before that. Oh yeah, that's fine. So which tail we are working with? One tail or two tail? One tail. Two tail is for the equal sign, not equal sign. If you use not equal sign in your alternative hypothesis, it's two tail. Except for the not equal, if you use bigger than or less than, doesn't matter which one, it's always one tail. So one-tailed, our alpha is 0.05. Now, which one you have to use? The Z or the T?
Z.
Why Z?
Because we get the standard deviation.
Population standard deviation. You may not recognize it, but think about this scenario logically. That teacher, we have no idea how many students he has, right? He may have 1,000 students. Maybe he's comparing all the students he taught so far in his life. In that case, maybe he had 10,000 students. Who knows? So we don't know the number of his students. So we assume that number represents the population because he already giving us a number for the sample, a sample of 81. So that 90 mean square of 90, we got that from the sample. It means the two numbers we have, 82 and 20, they represent the population, not the sample. They did not mention it directly in this scenario, but we use common sense logic and we figure that out. Since we know the population standard deviation, so we are going to use one-tailed Z alpha 0.05 to find the critical value. We're going to do that later. But first, we need to find the Z statistic using the formula. So x bar minus mu over sigma square root of n. What is the x bar here? How much is it? 90. Do we know what's the mean here? See here, we are clearly saying in the hypothesis, null hypothesis, that our mean is 82. That thing comes here. Our mean is 82. Our standard deviation for the population is 20, and we have total 81 students. What do we have? If you use scientific calculator, you must use parentheses. Otherwise, the answer will be wrong. 3.6. How much is the critical value for one tail alpha 0.05? Which number? One tail alpha 0.05. What's the number we have for the critical value for Z? 1.645. So one tail Z alpha is 0.05. They meet at 1.645. So this is 1.645. So now we have the two things we need to compare. What do you notice? Which one is bigger? Stat. So Z stat is bigger than Z critical. Do you reject or fail to reject the null stat? Z stat bigger means we reject the null. Actually, let me write RAC. We reject the null. It means we have enough evidence to support this claim this time because we're rejecting what we initially believed. I don't have the conclusion here, so let me write the conclusion here. We have enough evidence, and we should mention the alpha level at the alpha level 0.05. We have enough evidence at the alpha level 0.05 to support the alternative claim. You can mention the whole claim, but if you're lazy, you don't have to write the whole claim. You can simply say the alternative claim. Alternative claim is the mean is bigger than 82. And it makes sense now. 81 is a big number, right? So by observing 81, yep, we can make a conclusion that the mean exam score for his students is bigger than 82. That means he's a very good teacher, or his students cheated a lot, right? Either one or two. Ramesh, what are you doing? Any question on this? Huh? Can I flip my page? Okay, so we've seen two examples with Z. Now, a little details about T. So in this section, we are going to do one sample T-test. And if you want to know a little bit about T-test, one sample T-test determines whether or not the sample mean is statistically different from the population mean. While significance tests for population proportions are based on Z, so population proportion is always based on Z, always. And it's normally distributed. Hypothesis testing for the population mean depends on whether or not the population standard deviation is known or unknown. So if you're working with mean, you have to check, do you have the population standard deviation or you don't? If you do, that means you're going to use Z statistic. But if you don't know the population standard deviation, you need to use the T statistic. The one sample T-test is used for hypothesis testing of one sample mean when the population standard deviation is unknown and our sample size is relatively small. When can we use this test? We can use this test for continuous data. Your data should be a random sample from a normally distributed population. All the details you can ignore. This is same as the Z, whatever I told you in Z. Now, but the p-value of the t-test. P-value of the t-test is a two rules. If your alternative hypothesis is one-sided, then use the test statistic and degree of freedom to get the p-value from the table and compare that with the alpha. And if the alternative hypothesis has not equal sign, we get the p-value from the table, right? But they have to multiply that by 2 because it's two-sided. Bad news is that the table we have is not 100% accurate. Okay? So it doesn't have all the numbers we're supposed to have. So unless you're using a statistic calculator which gives you the p-value directly, or some type of websites that gives you the p-value directly, using the table is not always the best choice we have. We can use it, but it's not the best one. If you have only a table of values for t, then it's not so good. That's why using the critical value is better than working with the p-value. So the rules are same. As long as the test statistic is bigger than the critical, we reject the null. And if it's smaller, the critical value is bigger and the other one is smaller, then we fail to reject. Just like Z, the same rule. To find the confidence interval in chapter 9, we always use 2 till alpha. Okay? So the table we have, look at the table we have. So if you want to use the table, this is the table for the critical value for T. And on the top, we have 1 till and 2 till. So if you are doing hypothesis testing, you are going to use 1 till if your alternative hypothesis is one-sided. But if the alternative hypothesis has the not equal sign, then it's 2 till. And for chapter 9, for confidence interval, it's always 2 till. Okay? And if you want to use the p-value to work with, then this is the table you're going to work with. I don't like this table, but I want to give this to you anyway in that sum. But I prefer using the critical value because it looks much cleaner and nicer, and the numbers are cuter. So for confidence interval, it's always two-sided, but for hypothesis testing, it's not always two-sided. It depends on the alternative hypothesis. This is what I'm telling you in the right page. So we have enough information to do rest of the examples. Many employers are concerned about employees wasting time by surfing the internet and emailing friends during work hours. Real life scenario, right? The article Who Goofs Off 2 hours a day? Most workers, survey says. By blah, 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 summarize that from a large sample of workers. Summarize data from a large sample of workers. Suppose that the CEO of a large company wants to determine whether the mean wasted time during an 8-hour workday for employees of her company is less than the mean of 120 minutes reported in the article. So who goofs off 2 hours a day? In that article, they did a survey or researching something, and then they figured out that based on a large group of people, 120 minutes, the mean time they waste on surfing internet is 120 minutes. Okay? So the large group, they did not mention how large. They're saying a large group of people. So this large group of people, does it represent sample or population? Population. If it was a sample, they would tell us that a sample of this, or they mention the number, and based on the number, we could figure out sample or population. But here, they're simply mentioning that we have a large, it is a large sample of workers. It did mention sample, but it's large. So when we have a large sample, it kind of represents population. So they found out that based on that, we have a mean 120 minutes. 120 minutes is 2 hours. Wow. They work 8 hours, but they always 2 hours. So how many hours they are working? Plus they have a lunch break, right? Plus they have gossiping time. So how many hours actually they are working? I wonder. So the CEO wants to know, the CEO is claiming that her company, the people they are working is more serious. So they waste less than 120 minutes, a mean of 120 minutes. That is her claim. Our job is to figure out whether it's true or not. And we have a sample of 10 employees only. Really? We have a sample of 10 employees, and we got the result that the 10th employee has a mean wasted time 116 minutes with a standard deviation of 9 minutes. Only based on 10 employee, she wants to check her claim that most of the workers in her company waste less than 120 minutes. If it is common sense, what are you going to reply? Like, can you make a conclusion based on the sample? No, right? 10 is a very small amount of people. So probably we're going to fail to reject them out, most likely. Right, so 116 is 124 minutes apart. It's basically 2 hours anyway. But anyway, they want to make our life miserable. So yeah, we are doing this. And we have another 0.05. But in the exam, you're going to have actually a mix. 0.05, 0.01, 0.1. There will be a mix of all those alpha levels. Okay, let's start with our hypothesis. What is our null hypothesis? If you're confused, go with the alternative first. Alternative is a claim.
I was gonna say the null is that the average time is.
So equals 120. What equals? Population mean. Here you're working with mean. Anytime you see mean, it means the mu for population. So what is the claim? She is claiming what? The mean time is, but they specifically said less than. It's less than 120 minutes. So we are testing, is the average wasted mean time is 120 minutes, less than 120 minutes. So which tail? One tail or two tail? One tail. Bigger than or smaller than is always one tail. One tailed. Which one you're going to use, T or Z? Remember, for Z, we need to know population standard deviation. We have to use T because they are telling us sample standard deviation. S means sample standard deviation. So it's two-tailed t-test, alpha level 0.05. Oh, my 5 is not visible. One-tailed t-test at alpha 0.05. So let's go to find the test statistic. This time is T statistic instead of Z. The formula is same. Okay? The only difference is we have x bar minus mu over s square root of n. So previously we had sigma on the denominator, and now we have s instead of sigma. So 116.80 minus 120, standard deviation is 9.45. We are dividing by square root of 10 people. What do we have? Negative 1.07. So we are going to take positive. Because when you compare, we only compare the positive result and the negative. Now for T critical value, we need two things. One is alpha, it's one tail alpha 0.05. And also we need to know the degree of freedom. Do you remember what is degree of freedom? It's n minus 1. It means 1 unit less than your sample size. So in our case, we have 9. So 9 degree of freedom with 1 tail alpha 0.05. We go to our Q table. 9 degree of freedom. Degree of freedom is on the left. So 9 is here. 9 is here. Sorry. This entire row is 9. And we go to 1 till 0.05. So 1 till is here, 0.05 is here. It's how much? 1.833. 1 till 0.05. 1.833. 1.833. 1.833. 1 till alpha, degree of freedom 9. The table is telling us take the number 1.8. So we have T critical versus T statistic. Which one is the guy? Critical. So what is our conclusion? What is our result here? Do you reject or fail to reject the null hypothesis? Fail. And see, we assumed it before, right? We used logic and realized that, well, it wouldn't make sense. So we fail to reject the null hypothesis. Since we fail to reject this, so the conclusion we are going to make, conclusion is we don't have enough evidence at the alpha level 0.05 to support the alternative claim. Just by observing 10 people, sorry, we cannot tell you the mean time they waste in your company is less than 120. It could be 120, but it could be even more than 120. We don't know. Clear?
I just want to double check. Use the Chp10 because we do the sample standard.
And we use the z-test for the previous two examples because we knew population distribution. Why? I actually don't know. They are telling us if you want to find the critical value, you need to know how many people you are working with and what is the confidence level. So when you work with number of people, in order to be accurate or a little bit more accurate, they subtract one so that let's say you are assuming we have 10 people. Well, so well, maybe you're not actually using 10 people, probably have 9 people. So let's go 9 people. So just to be sure that we have what you're claiming, we deduct 1 from the total size. And the confidence level is how confident you are. Are you 90% confident, 95% confident? How confident you are? So how confident you are based on how many people you have. Combine them, go to the table, you get the number. Any other question? No? Okay, let's do one more. The article oil-fed crickets bowl maidens over what a name. Reported that female field crickets are attracted to males that have high chirp rates and hypothesized that chirp rate is related to nutritional status. Really? I think these people have so much time in their hands. Investigators fed male crickets a high protein diet for 8 days and measured their chirp rates. The usual chirp rate for male cricket is 60 chirps per second. Chirp means their noises, right? Crack, 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 those sounds. So their usual rate is 60 per second. After the diet, the mean chirp rate was 109 chirp per second. Really? They believe for population, it's 60 per second. And after the protein diet, it increased to 109. Wow. With a sample size of 32, and it has a sample standard deviation of 40. So based on 32 crickets, they found that the mean chirp rate is 109 chirp per second with a standard deviation of 40. Where initially we believe that for the chirp population, for the cricket population, it's 60 chirp per second. So, based on the 32 crickets they observed, do we have enough convincing evidence that the mean chirp rate for crickets on a high protein diet is greater than 60? That means they will attract more cricket ladies. Which should be a bad thing, right? Because then you're going to get more crickets. That means you're going to hear more noises. But we don't hear crickets here, right? No. We do? I never hear them here. Where do you hear them? Grounds or park? Yeah, where we hear grass and forest things in there. Yeah. So yeah. Do they? They're vegan? They're vegan. They don't eat. They eat each other? Really? Wow. They're vegan, but they eat each other. How stupid they are. They need to be here to Learn some statistics. Okay, go ahead. Which type of test you're gonna do? Z test or T test?
Yeah, frequency.
You do?
They do, they're all.
Wow. Then I shouldn't say that. I shouldn't say that they're stupid. It's just their.
Wow.
Yeah. Huh? Mosquitoes. Because cricket doesn't bite you, right?
No.
But mosquitoes they do. I hate those. Okay, so which test? Z or T?
T.
T. Why? They give us sample standard deviation. So go ahead. Oh, and we always have to start with hypothesis. What is the null hypothesis? What is the alternative hypothesis? Alternative is easy because that's the claim they're claiming. What they are claiming. So that mean, are you supposed to use X bar or mu? Mu. Remember, hypothesis is always for population. So they're claiming the mean is bigger than 60. So what is null? Equals to 60. So based on the alternative, you already know which tail you are working with. One tail or two tail? One tail. One tail. What would be your degree of freedom this time? Degree of freedom is 1 unit smaller than your sample size. So it's 32 minus 1, which is 31. And what is your alpha level? Now we have a different alpha level, 0.01. So to find the critical, we need to go to 1 till alpha 0.01 with the degree of freedom 31. So go ahead, find the test statistic, and I'll show you the table to find the critical. How much? 6.93. A big one. Now in the table, we have 1 till 0.01. Our degree of freedom is 31. If you observe, there is no 31. We have 30, 40, 60, blah, blah, blah. So when you don't have the degree of freedom you're looking for, we go to the closest one. So which one you to use? 30 or 40? 30. So degree of freedom even is 31, but given it's 30, our alpha level is 0.011 0.01, 1 till 0.01 is 2.457. So on the top it says 1 till, the top row is 1 till, the bottom row is 2 till. So top row 0.01, And here we have 30 degree of freedom. I forgot the number already. What did I say? 457. 2.457. Our T critical is 2.457. So if you compare T critical versus T stat, which one is bigger? Stat is bigger. So what conclusion you make? Do you reject or fail to reject? We reject the null hypothesis. Since you're rejecting this, so do we have enough evidence to support the alternative? We don't have enough evidence to support the alternative. Which one? We do. So we have enough evidence at this alpha level. Depending on your alpha level, you actually get different results. So that's why you should always mention in your conclusion that your alpha level is this, and at this level, we have enough evidence to support the alternative claim. And an alternative claim is the chirping rate that 14 bar makes its mean chirping time bigger than 60. So those 14 bars are effective, positively effective. And if you want to write in details, this is what you write. That we have enough convincing evidence at this alpha level that the mean chart rate is better for male gaps if they eat a high protein diet. So if you are lazy like me and don't want to write all the details, you can simply write, well, we have enough evidence to support the alternative claim. That's the alternative claim. And we have evidence at this alpha level. So I didn't do many questions from the review sheet. Review sheet. But they all follow the same thing. Okay. So find them by yourself. And I actually, if you want to know the results, email me. I'll tell you whether you're correct or not. So we have 6 questions in chapter 10 in the review sheet. We went over 4 of them. We missed 2, but it doesn't matter. You can do that by yourself. Only 1 or 2. Okay, so you're done in chapter 10. Yay! So in our next class, we are going to study chapter 11. I already posted the lecture material. So if you want to read ahead, go ahead. Read ahead. If you have any questions, ask me in our next class. I'm saying this one. You not because I did not. Okay. I will love you. We saw his Monday for last year. Yeah, but I actually like them and saw them last year. I will bring them next time. Okay, Professor, I want to know specific exam is 1 week ahead, right? Yeah, so 2 weeks from today. 2 weeks from today. So, I did want to ask in the class, but you're too shy. A little bit. Don't be shy. The question you have, probably many of them. Yeah, I think they asked it, but maybe because I was sitting like far. But I did write them below. So we use the Z table for population, right? And then we always say population. The Z is for 2 scenarios. When you're working with proportion, it's definitely Z. Okay. And when you're working with mean, then it depends on your information. If they give you the population standard deviation, then you're going to use Z. If they do not give us a population standard deviation, then we use T for mean. But for proportion, it's always Z.
So for proportion, not population, right?
Population, proportion.
Okay. And then said we use T table when we have the standard
Or-
deviation and
For sample,
samples. Okay. And the degree freedom we only use for sample.
degree of freedom is only used to the T, not in the Z.
Yeah, for the sample, right?
Sample -1.
Yeah. So I just want to make sure Z table is for proportion.
And when they give you population standard deviation, the mean population standard deviation and population standard deviation.
Thank you.
You too.
Oh, I think